Question is given कि the average separation between proton and electron in a hydrogen atom in ground state. So this is proton, this is electron. The average separation between proton and electron in the ground state of hydrogen atom is, that is 5.3 into 10 to the power minus 11 meter. Average separation is 5.3 10 to the power minus 11 meter. Calculate the Coulomb's force between them in this at this separation. So find the force value in this case. Force equals to how much? Force equals to K naught into Q1 into Q2 divided by R square. So that is the force value. Force equals to K naught Q1 Q2 by R square. So that is 9 into 10 to the power 9. Q1 equals to how much? Q1 equals to, that is proton. Proton is 1.6 10 to the power minus 19. So electron is minus 1.6 10 to the power minus 19. So that 9 into 10 to the power 9, Q1 is how much? 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 divided by how much? Divided by R square. Divided by R square. R square is 5.3 10 to the power minus 11 whole square. R square equals to 5.3 10 to the power minus 11 whole square. So after solving this equals to 9 into 1.6 into 1.6, that is 2.56 into 10 to the power 9 minus 38. So 9 minus 38, that is minus 29. So 9 minus 38, that is minus 29 divided by 5.3 square 10 to the power minus 11 square. So 5.3 square, so that is 5.3 into 5.3. 5.3 into 5.3, so that is 28.09 into 10 to the power minus 22. So 28.09 10 to the power minus 22. So that equals to how much? 9 into 2.56, that is 9 into 2.56, 23.04. So 23.04 divided by 28.09. So that equals to approximately 0.8 into 10 to the power minus 29 plus 22. So that is minus 7. So 0.8 minus 7 Newton. That is the force value. Force equals to how much? Force equals to 0.8 into 10 to the power minus 7 Newton. That is the force value. Force equals to 0.8 10 to the power minus 7 Newton. That is the force value. So that is in the first case. So what will be in the second case? So in the second case, when the atom goes into its first excited state, the average separation between the protons and electron increases to 4 times its value in the ground state. So what is the Coulomb's force in this state? So it is given that when the atom goes into its first excited state, the average separation between proton and electron increases to 4 times. The average separation between proton and electron increases to 4 times. Separation increases to 4 times. 4 into 5.3 into 10 to the power minus 11. That is the separation. So this is proton. Proton is 1.6 10 to the power minus 19. Electron is minus 1.6 10 to the power minus 19. So that is proton value, that is electron value. Separation is, this is the separation. And force equals to how much? Force equals to K naught into Q1 into Q2 divided by R square. So that is the force value. So force equals to K naught is 9 into 10 to the power 9. Q1 is how much? Q1 is 1.6 10 to the power minus 19. Q2 equals to how much? 1.6 10 to the power minus 19 divided by how much? R square. R is 4 into 5.3 10 to the power minus 11 whole square. So that is R square. So that equals to how much? 9 into 2.56. So 9 into 2.56, that is 23.04. 23.04 10 to the power minus 29. 23.04 10 to the power minus 29. So this is 28.09 into 16. So 28.09 into 16. So that equals to how much? That equals to 449 into 10 to the power minus 22. So that equals to how much? So that equals to 5.3 whole square 16. So this is 28.09 into 16. So this is 449 into 10 to the power minus 22. So this is how much? 23 divided by 449. 23 divided by 449. So that equals to how much? That equals to 0.05 into 10 to the power minus 29 plus 22. So this is minus 7 Newton. That is the force value when separation increases to 4 times the value, 4 times the initial value. So that is the force between the proton and electron when separation increases to 4 times the initial value.